Hello, we are Braves Robotics. I am Caleb Schroeder,
And I'm Ethan Liff.
and this is our programming.
So we'll start up with the top box and work our way down. This right here was our autonomous programming. Here you'll see that if you were to press the top button and the left button by holding them down, it will start our autonomous programming that will go for the IR sensors. Here's just a little bit more of our programming. By triggering these two buttons, it will automate our autonomous mode. And here's a little bit more into our autonomous mode. So for the IR sensors, they will be observing the ground where the track is at. If it were to go off course, like let's say the robot's moving too much to the left, it will recenter itself back onto the right course so that we are able to score points with the autonomous programming.
Yes. The way it does this is that the three different colors on the track that the autonomous path follows, it goes black, white, black. The three IR sensors on the front of the robot each detect these colors, and depending on what color they see, it gives those IR sensors a specific input. If the left sensor detects black, the middle sensor detects white, and the right sensor detects black as well, then that means that it gives the same input to both motors and moves forward. I think it was 6 seconds, or no, it was every second that a the robot will move to the left if it detects
A
any,
color that it's not supposed to, it will recenter itself back onto the track and recenter itself.
like say if it detects white, black, black, it will turn to the left and recenter itself with the track. But if it detects black, black, white, then it would move to the right. Each color giving the motors a different input.
And here was uh, our IR sensor. There would be three of them, but here was just a singular IR sensor piece of coding right here. It's also hooked up to our autonomous. Here's our driving system. We were originally having a single joystick driving system, but our drivers preferred to have what we like to call tank controls, where one joystick controls one wheel and the other controls the other wheel. So moving both joysticks forward will make the robot go forward, and pulling them both the joysticks back will make the robot go backwards.
Yes. This is opposed to arcade controls, which most teams use, where it is one joystick that controls both motors.
Here's our arms programming, and we had some special stuff with this programming when it comes to the speeds of the motor. But we'll start off with the very beginning. This right here, we used the bumpers on the front of the controller. Pressing the up bumper will lift up the arm, and pressing the downward bumper will lower the arm. Both of these are operating at a speed of 60 because with the original speed of the motor, it was getting way too jerky with how fast it was going up and down. So we slowed it down so that whenever we are operating on the game floor, it's not going to be a really jerky arm.
Yes.
Here was our DVD player, and this was probably one of the coolest parts of our robot. So our DVD player was a tray that shoots out from the bottom of the robot. Pressing the upward button would shoot out the DVD player. Pressing the bottom button would suck the DVD player back in. And here was more of the programming towards it.
We used a state flow program because we had a couple of issues with the DVD player in practice where we would either hold it down and shoot it out too far and it wouldn't come back in, or it would just completely fall off the robot completely. So what we did to counter this issue was we made a state flow program where it shoots the DVD player outwards for a specific amount of time at a specific speed to where it shoots out to the perfect length to where it can catch the plaque and not go too far as to where it will not retract properly. think that's it.
I believe that is all of our programming.
It is, yep.
Thank you. Have a great day.
Have a good day.